Today's topic mathematics and physics ninth part. The most important part of mathematics and very useful in physics is calculus. So calculus actually it is divided into differentiation and then integration. First, before learning about differentiation, we need to learn some terms which are related to differentiation and also related to integration. The first one is a constant. So what is this constant? It is a fixed real number which value does not change. For example, for constants, example 3 is a constant. Its value never changes. Similarly, minus 8 is also a constant. E, exponential value which is equal to 2.718 is a constant. Pi, 22 by 7, 3.14 nearly is also a constant. So these are constant values and these values never changes with the time. But the second part is variables. A quantity that can assume any set of value. For example, the height of a tree. If you take only one tree, that tree will have some height. But if you take a garden, different trees will have different heights. So height of a tree is given by 22.4 meters. Is it constant or variable? It is constant at this time. Within 1 year, height of the tree will change. So that height of a tree is a variable. So it can assume any value, any set of value that changes with the time. Variable is a quantity that is changing with likely to change. Likely to change its value is called a variable. In this we have two types of variables. One is independent variable, second one dependent variable. So independent variable, it is a value whose value may change but does not depend on any others. But a dependent variable depends on some other variable or a constant. For example, if you take an equation y is equal to x square. If you take this equation, y value depends on x. So here we can write y depends on x. Y depends on x. So y depends on x. So y is a dependent variable where x is an independent variable. For example, the age of a person, a man, is 49 years. So this is a independent variable, does not depend on any other values. This man age is 49 now. But if you take the age of a man changing, age of man changes from day to day, That means with the time his age is changing. But this is a fixed value. But it is varies. Fixed value is 49 is a fixed value, constant. But it is only constant for this year. For next year it will become 50, then 51, 52. Age changes. So that is an independent variable. Does not depend on other values. Dependent values depends on other independent variable. Next one is a function. So function is it's a rule of a relationship between two variables. Remember, function always is the relation between two variables, in which one is a dependent variable, the other one is a independent variable. So function always gives the relation between dependent and independent variables. We will see some examples here. First one, Boiling point of water, all we know, water boils at 100 degrees Celsius at sea level at a pressure of 1 atmosphere. The pressure is 1 atmosphere. Water boils at 100 degrees Celsius. This we studied in high school standard. But students, if you take the boiling point of water is a function of elevation above the sea level. That means if you go above a sense, let us say this is the sea level, this is the sea level, from the sea level, this is the sea level, from the sea level if you go up like this. Here, the boiling point of water is 100 degrees Celsius. If you go up, this may become 99.2 degrees Celsius. This may become 98.4 and it may become 96.8 degrees. That means if you go up above the sea level, the boiling point gradually decreases. Instead of boiling at 100 degrees, water boils below 100 degrees itself. Why? Because as the pressure changes, here pressure is 1 atmosphere, here less than 1 atmosphere. So as the pressure decreases, boiling point of water also decreases. So boiling point of water depends on pressure, or boiling point of water is a function of height above sea level. So this we can write. The boiling point, I will take this as B, is a function of this one. B of this is directly proportional to, that means B depends on elevation, sea level or height. Boiling point depends on height, as if you increase the height, if you go above the surface of it, boiling point decreases. So both are inversely proportional to each other. Similarly, if you take the second example, the interest paid on a cash investment depends on the length of the time the investment is held in that bank. Suppose if you keep 1000 rupees in a bank, so for 1 month, let us say you are getting 1 rupee 17 paisa interest. But if you keep the same amount for 2 months, this will become double, that will become 2.34 rupees. That means for this 1000 rupees, let us say they are paying this much interest. For the same amount, if you keep it for 2 months, the interest also increases. That means if time increases, interest also increases. So you can write interest paid is directly proportional to the time. So here, these are inversely proportional to each other. These are directly proportional to each other. So interest paid directly proportional to time. Here, time is a independent variable and interest is a dependent variable. So like this, in calculus, if you take a function, in the first example, boiling point inversely proportional to the height above the sea level. In the second one, interest directly proportional to t. So in general, we write, students, y is a function of x. Y is a function of x. This we can write y is equal to function of x. So y is equal to fx. So y is a function of x here. That means if x changes, y also changes. If x decreases, y decreases. If x increases, y increases. Now, if you take the area of a circle, let me take the area of a circle. We know A is equal to pi r square is the area of the circle. Here we have seen function is a rule of relation between two variables. Function is a rule of relation between two variables. Area is a variable, radius is also a variable. So the function will give the relation between area and the radius. And you can say area of triangle directly proportional to square of radius and multiplication of pi. Now, if you see this one, we can write this in form of an equation area directly proportional to square of radius, the square of radius, and then multiply with the multiplication of pi here, pi. So area is equal to pi r square. This is the relation. Now, in this, if you take a domain, you get a range of values. So this is a domain. The function y will have a domain. For the domain, you will get a range of values. For example, in this, if r is equal to 1, a is equal to pi into 1 square pi. Suppose if r is equal to 2, r square is equal to 4, 4 into pi, area is equal to 4 pi. If r is equal to 3, area is equal to 9 pi. Domain are possible inputs. All possible inputs are called domains, and all remain this corresponding outputs output values are called ranges. The volume of a ball, that is solid sphere, is given by volume of sphere is given by V is equal to 4 by 3 pi r cube. Find the volume when the radius is 3 meters. So r is equal to 3 meters. So it is clearly visible, students. The volume of the sphere is a function of radius. This is the relation and also the rule. So volume directly proportional to r cube. Now I need to find out volume of the sphere when the radius is 3 meter. So V is equal to 4 by 3 pi 3 cube, which is 1 by 4 by 3 pi into 3 into 3. Now you can cancel this 3 and 3. You can write 3 fours are 12 pi. As it is in meter, this will become meter cube. So this is a meter cube. Volume of this one sphere is 12 pi meter cube. In this problem, we can say the volume is a function of radius. Volume as a function of radius is given by 4 by 3 pi r cube. We will see one more problem here. Example 2. A function f of x, a function f of x is given by f of x is defined as, or f of r here is defined as f is equal to function as a f is a function of r, which is equal to 2 of r minus 1 plus 3. So the given function in this problem is f of r is given by 2 of r minus 1 plus 3. Now evaluate f at the input values when r is 0, r is 2, r is f of x plus 2 and f of 2 they are asking. Students, first one f of 0, because here r is equal to 0. F of 0, which is given by 2 of 0 minus 1 plus 3. This is 2 of minus 1 minus 2 plus 3. 3 minus 2 is 1. So f of 0 is equal to 1. Similarly, second one, f of 2 they are asking. So we can write 2 into, in place of r you write 2 minus 1 plus 3. That that is 2 into 2 minus 1 is 1 plus 3. 2 plus 3 is equal to 5. The next one, f of x plus 2 they are asking. That means in place of r you write x. So we are going to write 2. In place of r we are going to write x plus 2 minus 1 plus 3, which is going by 2 of x plus 2 minus 1 is x plus 1 plus 3. This will become 2x plus 2 plus 3, that is 2x plus 5. This is f of x plus 2. The last one, f of 2. F of 2 means f of 2 in place of r you have write f, or it is found f of 2 or when f is equal to 2. But it is function of f2, that is, please remember, f of 2 already we found here. F of 2 is equal to, here we found 5. Now they are asking f of 2, f of 2, that is f of, what is f of 2? This is 5. So f of 5 they are asking, because r value is 5. So this value will become 2 into r plus 5 minus 1 plus 3. So this 2, 5 minus 1 is 4, 4 2s are 8 plus 1, 11. This is example 2. Now one more example. A function f of x is defined as f of x is equal to x cube plus 3. Now we need to find f of 0, f of 1, f of x square, f of x plus 1, f of 1. So we need to find out these 5. So first solution, f of x is given by x cube plus 3. So in this first one, f of 0, that means x is equal to 0, you will get 0 cube plus 3, which is equal to 3. This is the first one. This is first one. Now we need to find out the second one. F of 1 we need to find out. That means in place of x you just keep 1. This will become 1 cube plus 3, which is equal to 4. Next one, f of x square they are asking. Wherever x is there you keep x square. So in this we can write, in place of x we are writing x square 4 cube plus 3, which is given by, in place of x square x we are keeping x square. This will become x power 6 plus 3. Next one, fourth one, f of x plus 1. In place of x we just replace that with x plus 1. So in place of x I am writing x plus 1 whole cube plus 3, which is going to, this is a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube. This is expansion of x plus 1 whole cube plus 3. And here you can see this is 4, which can be written as x cube plus 3x square plus 3x plus 4. And the fifth one is, f of 1. Students, already we have seen this, f of 1 is equal to 4. So this is nothing but f of 1 is 4. That is function of 4. So wherever x is there, you just keep 4 there. This will become 4 cube plus 3. This will become 64 plus 3. The answer is 67. Differentiation. In this differentiation, students, we have two types of differences first, which are known as in lower classes also, that is finite difference and infinitely small difference. Students, finite, that means it has a fixed value. We know this value. The finite difference between values of a physical quantity is represented by delta. This symbol is called delta notation. For example, let me take y2 is 100. y2 is 100 only. Every time y2 is 100. And y1 is let us say 99, 98, 50, like this. Now what is the difference between y values? Initially it was 99 and it increased to 100, 98 to 100, 50 to 100. So what is the change in y value? Y value changing. Or if this is y1, let us say this is y2. Initially it was y1 is 100, then y1 100 changes to 99. In second set 100 changes to 98. In third set 100 changes to 50. So change in y, change in y. So we write this as a delta y. This symbol is a delta rotation. Delta y is given by y1 minus y2. Or actually changes of final value minus initial value also you can write, but here I am writing magnitude of delta y. So 100 minus 9 is 1. 100 minus 98 is 2, 100 minus 50 is 50, and these are finite differences in a physical quantity or in a given value, in a constant value. But it is changing, it is not constant. These are the changes in variables. So y value changing from 100 to 99, 100 to 98, 100 to 50. Now what is this infinitely small difference? It is a very small difference in a given value. This difference is given by d instead of delta. A big difference given with the delta, a small difference given with the letter d. For example, let me take the same concept. y1 is equal to 100, same thing. But y2 now, this is not a big difference, students. Let us say this is 99.9999999 and so on 9. And if you observe these two values, this is 100, this is 100, and this is almost 100 but not 100, this is 99.99999. So now we can write dy is equal y1 minus y2, that is 100 minus 99.9999, which can be 0.000000 and so on 1. So you please remember, for a finite difference we use delta y. For change or difference, either we use delta, or for difference we use d. When we use d, this is for very small difference, we call it as a infinitely small difference d, and for bigger difference we use delta. Differentiation, students. Another name for differentiation is derivative. Suppose if you take a function, suppose a function is denoted by y is equal to f of x. Y is equal to f of x. So we know the meaning of this one. Y value depends on x. Now what is this differentiation? We know these differences, just now we discussed these differences. A difference is a delta for a finite difference and a d for a small difference. Now the differentiation of y is written as with respect to x. Y with respect to x is written as small change in y to the small change in x. If I write delta, this is a finite change, but if I write d, this is a small change in y. That means whenever x is changing, corresponding y value also changes. This is called dy by dx. This we can write it as y dash, which is also written as f dash x. Because here, if you observe this one, The given function is y is equal to f of x. And if we differentiate this one, this is how y changing with x. So here I am writing y dash is change in y. This is nothing but it is a function of changing x. Here dx is called is actually very small change in x value, and dy represents corresponding very small change in y value. So differentiation of a function is how the function is changing with respect to the independent variable. Here, how y is changing with respect to x. Changing means how y is differentiating with respect to x. How y value is different, how y is changing with respect to x. Most common notations of that is differentiation. Generally, differentiation is due to letter y prime. This is called y prime. Here, it's a nice and brief notation of differentiation. But if you can see, this will not name the independent variable. Generally, just now we have seen dy by dx. Y changing with respect to x. Here, y value changing with respect to x. But if you are writing this dy by dx, this can also be written as y prime. So whenever you are writing y prime or y dash, we call it as y prime. This will give y is changing. With respect to what we are not showing, that's why it does not name the independent variable. Second one, dy by dx, that is pronunciation is this is y prime or y dash, this is dy by dx, names the variables, and d is used for derivative. Derivative of y with respect to x or differentiation of y with respect to x. Most commonly used method of representing differentiation is this one, which is dy by dx. Dy by dx. This is the most commonly used method here. So this is dy by dx. Next one, the same thing, dy by dx or y prime or y dash can also be as df by dx. df by dx, pronunciation is df by dx. This emphasizes the function's name. So we are giving the name. And next one, d by dx of f of x. You know f of x is nothing but y only. The same thing, this is the d by dx of f of x is nothing but y. This is dy by d, both are same only. Here also emphasize the idea that differentiation is an operation performed on it. So we are doing some operation on this given function. Next one, dx of f. This is capital students. Dx of f, that is differentiation of function. So a common operator notation. And last one, y naught. So we will keep a dot here above this one. This is y naught. And this is Newton's notation. Newton, when he invented this calculus, he used this dy by dx. He wrote in his notes as y dot. That is simple. Just now common for the time derivative of displacement. Suppose if you want to find out velocity is displacement by time, change in displacement by change in time. So we can write this as velocity is derivative of y, that is y dot. That's it. Students, if you take a arbitrary function, for example y is equal to f of x, the meaning of this one is y is a function of x. As x changes, y also changes. So we have seen one diagram here. In the first quadrant, I am taking the x axis and y axis. This line represents, that means whenever x value is changing, y value also changing. So y is f of x. In this, students, if I take a particular value of x here, I am taking a particular value of x. Let us say this is x. So I am writing a particular value of x here. So this is x value. The corresponding y value is this. Similarly, if you take one more x value here, the corresponding y value will be this. That means with the x, y also changing it. So I am going to write here, if it is x, this is a x plus delta x. Here I am writing this as x-axis, this as y-axis. Similarly, for x, the corresponding y value is y. For x plus delta x, the corresponding y value will be y plus delta y. If we see this diagram, this is x and this is x plus delta x. So the difference between these 2 points in x value along x coordinate is delta x. Similarly, the difference between this point and this point along y axis is this is a delta y, because this is change only. Now from this, what we are going to write? The average rate of change of y with respect to x is given by. So what is this average change of y with respect to x? That means change, small change in y by small change in x. Even though diagram is a bigger one, if you minimize this diagram, that delta x can also be written as for small changes we can write this as dx, and for small changes we can write this as dy. These are finite values, these are very infinitely small values. So what is dy by dx? This is a change in y for the corresponding change in x. Now in this diagram, if you observe the diagram clearly, in this we can write this is delta x and this is delta y. This is, I will write this as a very small value dy and a very small value dx. And let me give the names here. Let us say this is p, this is q, this is r. From the diagram we can see this dy by dx is nothing but how the y value changing with respect to x. That means final value is y plus delta y, initial value is y. So corresponding, this is also change of this one. So we can write function x plus delta x is the final value. So for x plus delta x value, y value is y plus delta y minus change, we need change in y value. So this is final y value and the initial y value is f of x, because the given order function is y only. So this is y, this is final value minus initial value of y by, and change in x, this is x plus delta x is the final x value, initial value is x. So we can write dy by dx is equal f of x plus delta x minus f of x, xx get cancelled into delta x. So this is the fundamental formula of differentiation, because I am finding dy by dx, and this we call it as fundamental formula. Fundamental formula for differentiation. And you can see, students, this dy by dx, if you observe this diagram and if you draw a line here, this is a right angle triangle, and in this right angle triangle we can see this is angle theta. So what is this theta? To find out this one, let me take tan theta is equal to the triangle PQR. Tan theta is by opposite side by adjacent side. Opposite side is RQ and adjacent side is PQ. So this RQ by PQ, RQ is nothing but dy and PQ is nothing but dx, but this is a derivative. That means tan theta is also called slope of this line slope is equal to change in y value by corresponding change in x value, that is the differentiation of y with respect to x. This is delta x, this is delta y. When this will become dy and dx, delta is used to denote finite differences, but d is for infinitely small differences. Now if you take the same diagram, students, in this, if you take this small diagram and if you decrease the size of this one, now you see this is very, very small. Small changes can be written as dy and corresponding change is dx. Actually this is a delta x by delta y, this is a delta y by delta x, and when the changes are very, very small, that means the delta x is very, very, very small and tends to 0. So if delta x tends to 0, then the function limit of delta x tends to 0, delta y by delta x can also be written as, because delta x is very, very small, equal to 0. This is nearly 0, almost tends to 0. Then this will be very small, this is also very, very small. Then you can write this as dy by dx. So please remember this difference. Here also the change in y for bigger diagram we can write this as delta y by delta x, and this is also delta y by delta x. But when we can write this dy by dx, delta y by delta x for finite values and dy by dx for infinitely small values. Then infinitely small values, this is we call it as differentiation of y with respect to x, but this is a change of difference in y by difference in x, but this is a differentiation of y with respect to x. We call it as derivative of y with respect to x.